Okay, let's get started talking about polynomials. Okay, so first let's define a polynomial. So a polynomial is an equation. It could be an expression that follows this form. Let's see. F of x is equal to a sub n x sub n plus a sub n minus 1 x to the n minus 1 plus a sub the n minus 2 x to the n minus 2, and then plus all of this stuff in between, plus then let's say a cubed x cubed plus a to the second x squared plus a to the first x to the first power plus a naught, where n is an element of the positive integers, meaning it's a whole number and it's positive, and a sub n is not equal to 0. Okay, so that's all the technical stuff, but this is basically the definition, and you guys have been seeing polynomials for a while. Basically, the main thing that we need to keep in mind here is that there are no rationals. Okay, and also that there are no rational, get a little crazy with my rational exponents. Rational exponents end with root. The roots, you know, square roots, cube roots, fifth roots, stuff like that. Okay, so let's just look at some equations here and determine if they are polynomials or not. So determine if a polynomial. Just by giving the equation here. So let's see, y is equal to 3x cubed minus 7x squared plus 6x minus 3 all over 2. So, is this a polynomial? Yes, it's a polynomial. Even though there is a denominator here, this could be very easily written as just fractional coefficients. So that guy, yes, is a polynomial. Let's look at this guy here. 5x to the 4th plus 7x cubed plus 2x plus 1 all over x. This is not a polynomial. No, this is rational. And you may want to argue that we could simplify this, and if we were to simplify this, we could get this as 5x cubed plus 7x squared plus 2, but we would still have this rational piece, 1 over x. This is the rational piece. So this would not be a rational function. Let's see, let me throw a couple more examples out there real quick. One third x to the 5th minus 2x squared plus 1/15. This is, yes, this is a polynomial. The coefficients can be fractions. Okay. Let's see here. Taking a look at this guy, this is definitely a no. And it's kind of a rational. And we know that because we have that variable in the denominator. But another way we could also write a rational is with those negative exponents. Don't forget what those negative exponents mean. This is also no. It's a rational. So basically, the only thing that's going to mess this up is if the polynomial, either the entirety of a polynomial or just a term in that expression, is divided by a variable, then it's not going to be a polynomial. I think I've done a pretty decent job. Oh, one other kind I did not think of is, I mentioned it, but I didn't show you one. So a rational. Exponent, notice that here the exponent is a fraction. And if you remember from your previous stuff, that means that that is a radical. And in fact, here it is a square root. Okay, and so that is no, not a polynomial. A rational. It's actually a radical equation. Okay, and let's see, let's give you a couple to do. So one of the best things about having a videoed lecture like this, and this is a lecture just like I would do in my classroom, so the best part about having a video lecture is you can pause it, you can stop, you can go backwards, you can hear that again, you can look at how I worked that problem again. So what I will be doing is on major concepts or whatever, I'll give some you do problems where I'll give you a problem and then I'm going to wait 10, 15 seconds before I talk about the solution of that, giving you time to try the problem yourself. I want to encourage you to pause my recording. If I've not given you enough time to completely finish the problem, I want you to pause my recording so you can finish that problem and then come back and kind of check your work with my worked out solution. Okay, so here is our you do, and what I want to know is, are these polynomials? So first one, and then the second one. So I'll give a couple minutes here. Okay, the first one here is yes, it is a polynomial. even though it has fractions, those fractions are either coefficients or the constant, so that has nothing to do with fractions in the exponent. This second one here is no, and that is because the exponent of 3/2. Okay, that indicates that it's radical, therefore not a polynomial. All right, so another thing that we want to talk about polynomials is defining the degree of a polynomial and the turning point. So let's look at the degree of a polynomial. Okay, so there's two different ways that a polynomial is going to be given to you, and one of the ways is in general form, and that's that form that I showed you on the last slide, but I'm going to just write an abbreviated version of that. And I'm going to leave out all that other gobbledygook that I had to write formally, but all that still stands. All these powers of all these n's are positive integers, meaning whole numbers that are positive. Okay, so when the general form is given, for example, let me just say f of x is equal to So say this is our example here. Though the degree is given by the highest power of x. So when in general form, the degree is the highest power of x. Okay, so here we could easily say that our degree is 6 to the 6th power. Okay. Now, there's another form that the equation can be given to you in, and that could be in factored form. And factored form looks something like this. And it could go on. Let me do a couple more. Okay, so this would kind of be in factored form, and let me write out one so that you can like wrap your brain around what I just wrote and all this weird gobbledygook. So if we had something like -2 times x minus 4 squared times x plus 2 cubed times x minus 1/3 to the 5th times x plus pi to the 2nd, and we could go on and on here, but notice that the deal is this is in factored form, meaning that nothing is plus or minus outside of those actual little factors, and those factors could be raised to a power, they could not be raised to a power. Okay, so when you're deciding what the highest power is, and it's in factored form. So when in factored form, we add up all of the powers. So when in factored form, we sum up all the exponents. So in this particular case here, we have 2 plus 3 plus 5 plus 2. So here we have a degree of 2 plus 3 plus 5 plus 2. So 5 and 5 is 2, so degree 12. Okay, but it's important that you can recognize the difference when it is in factored form, which, by the way, is going to always be our desired form. If we can have something written in factored form, then we can do a lot more things with it than if it is in general form. So our goal this chapter is to make it so that we can do everything in factored form. Okay, so what goes along with degree is something called turning points. And let's look at the turning points. And for me to really talk about turning points, I need to get a little bit visual with us. So I'm going to draw some really quick sketches of a couple of really kind of not very fancy graphs here. But I'm sure that you can kind of recognize these. This one is linear, so that means f of x is equal to x of some kind, right? We're just being really, really loosey-goosey here. This isn't really the equation. If it was the equation, it'd be going through 0. It would be very, very specific. But this is just generally. This is quadratic, so this is going to be something like f of x is equal to x squared. And in fact, this is pointing down, so it's a negative x squared. But we're not going to get in the weeds here. We're just talking about what those general forms are. And so if we can follow the pattern here that this is going to be an x cubed, and then this guy is going to be an x to the 4th. Now, I drew these so that we could take a look at turning points, okay? So, and a turning point happens when the graph direction changes. So basically from going up to down, or down to up, increasing to decreasing, decreasing to increasing. And so if we look here at the linear, which, by the way, the exponent on this x is just a 1. I'm just going to point that out because I'm going to talk about a rule. But if we look at the linear, there are no turning points. So here for the quadratic, there's one turning point. Right here where it goes from going up to going down. Here it looks like we've got 1, 2 turning points. And in fact, we have exactly one less turning point than the degree. So 1, 2, 3 turning points. So we don't actually have to have a graph to be able to know how many turning points there will be. So the turning points of a polynomial of degree n are, or is, are n minus 1. So if I had f of x is equal to 11x to the 12th plus 7x to the 6th plus 2x minus 3, we could say two things here. Our degree is the 12th, and there are 11 turning points, meaning that the graph is going to change directions in 11 times. Now, those actual turning points produce something that is very, very sought out in calculus. So it's really important that you understand this turning point idea, and when they occur, we'll talk about in calculus, but you need to start being aware of them now. Okay. All right, so got that, did that with some sketches, talked about how many turning points. I don't really think you need a you-do on this topic, no need to belabor it. So let's move on to something else that I feel like you should have already had some experience with, so I'm going to kind of glance over it a little bit. We'll do a few examples, maybe 4 examples. This won't be a particularly long lecture today. Okay, so the next thing we want to talk about is transformations of graphs in standard form. So first, let's talk about standard form. And I know you did a whole section, or I feel like you should have done a whole section in your college algebra course, and certainly in your high school algebra classes on graphs and transformations of graphs and stuff. So let me just give you the standard form. Let's just break it down here. Now, this n could be anything, but right now we're talking about polynomials. So here, n is going to be a positive integer, and with that being the case, it forces polynomials. Okay. All right, so it's just like it's worked as you've learned it before, I'm sure. A is the amplitude, and that's the stretch or the shrink on the y value. Okay, the h, that stands for the horizontal shift. That's the shift this way, horizontally. And that has something kind of special. You're going to do the opposite direction, and it's the opposite direction because there is this built-in negative sign here. So if it is a positive 2, it's going to say x minus 2, but if it's a negative 2, it's going to say x plus 2 because of that negative sign that's built into the form. So you'll be using the opposite of whatever that is. And then k here, k is the vertical shift, And that you're just going to be straight up. Notice that there is not a negative built into that, so it's just going to be as you see it. If it's a +5, you're up 5. If it's a -5, you're down 5. Straightforward. Okay, now in the homework, and you've already graphed a lot of these things in your previous classes. So really in the homework, all I'm going to ask you to do is describe the transformations. There might be a couple of them where they've got a graph that you've moved or something like that. But in general, I'm just going to ask you to describe the transformations. So let's do a couple of examples here. So let's see. We'll start off easy. So looking at this one, if we're to describe those transformations here, we notice that we have a horizontal shift of 3, and it's going to be going to the right, even though that says x minus 3. Remember that minus is built in, so this is actually a +3, so that's 3 units right. And then we have k, and our k here is equal to 6, and that's 6 units positive, so up. Let's look at this one here. Here we actually have an A, and our A is -2. So we're going to flip and stretch by 2. Now we flip because it's negative. That's our flip. And the stretch is whole number stretch and fractions shrink. Okay, so we stretch with the whole number and we shrink if it's a fraction. Okay, alrighty. And then what else do we have going on here? We have an H also, because we have something happening directly to the x inside those parentheses, and that is a 2, and because it is a +2, and accounting for that negative in the formula, we're going to go 2 units left. Now I feel like this is very much sorry, my brain, very much review, but let's just do another one here. And I'll just make it ugly with all those lovely fractions, and I'll even put in another crazy number like pi, just for the craziness of it. So here we have all 3 here. We have an A, and our A is 2/5, and that means that we are going to compress or shrink by 2/5. Okay. Our horizontal shift is going to be 1/3 unit left, because it's a plus, and we do the opposite. And finally, our vertical shift is pi units down. I don't think you need any extra practice here on this particular idea either. I know that this should be very much review for you. You'll have some practice in the homework. Okay. All right. So let us look at what a 0 is, because this is really where we're going. Zeros is is what we're going to spend the next couple of sections on. So let's look at what the zeros of a polynomial are. Now, hopefully you've learned this before, but if you haven't, that's okay. I got you. The zeros of a polynomial have other names. Zeros are also equal to roots. We use the term zeros when an equation is written in a function format. So like f of x is equal to blah, blah, blah. That we would talk about it in terms of zeros. But if a function was set up as an equation, we would be talking about roots or solutions. Now, there's one other thing that ties all this together. So we have zeros and we have roots, we have solutions, and we also have, so zeros if it's written as an equation, just as a function, so zeros as a function. I'm not going to test you over this, but I found this to be quite interesting, and I was always confused on why we had 4 different words for the exact same thing. It's frustrating, but it happens a lot in math, okay? So we use zeros if it's written as a function like f of x is equal to x. In that case, we would use it as a zero. We call it a root if it's an equation, like x is equal to 0, or solutions if it's an equation, you know, like x is equal to 0. But there's, what do we do when it's a graph? It's called x-intercepts. If it's a graph. And that's usually written in this kind of form, right? Okay, so know that these all mean the exact same thing. And another thing I could throw in there is factors. Okay, so zeros of the polynomial happen, and there's a lot of different ways to talk about them. So let's look at how to convert zeros to factors. Okay, and the way we convert zeros to factors, we have this little form, x minus whatever the 0 is. Ta-da! It's a factor. Okay, so let's see, where are we even going with this? So let's find a general. Let's find a general polynomial. With the following zeros. Let's see, 1, -2, and 3. Okay, so if we want to find a general polynomial, the first thing we need to do is we need to write the zeros as factors. And then secondly, we're going to multiply together all the factors. And then third, we're going to say f of x is equal to a times that polynomial. Okay, so let's take a look at this. So first, let's get our factors. Here are our zeros, 1, negative 2, and 3. So our first factor is x minus 1. Our next factor is x minus a negative 2. You see what I did there? I minused a negative. I've been doing this since I learned algebra. And by the way, I did not learn any algebra until I started college at almost 30. So I've been doing this for many years, but this is the way that I handled that. And then x minus 3. Now, remember this from your algebra classes. You cannot multiply these three guys together at the same time. You can only multiply binomials and trinomials or polynomials 2 at a time. You can't do multiples. So I'm going to multiply these two guys first. X squared plus x minus 2. Okay, so I multiplied those together and got that. Now I have an x minus 3. Now, I can do 2 really quick in my head. 3, probably, or, you know, a trinomial to a binomial, a little bit more difficult for me to keep up with. So I'm going to write this one on out. So we have x squared times x is x cubed minus 3x squared. Then I'm going to pick up here, x times x is a plus x squared. I'm a stacker, so that's how I'm going to do it. And x times negative 3 is minus 3x. And then finally picking up here, negative 2 times x is a minus 2x. And a minus 2 times a minus 3 gives us a positive 6. So let's just come down here and see what we got. So here we have a general is f of x is equal to a times x cubed minus 2x squared minus 5x plus 6. Now this is general form because from this, the zeros, we can have an infinite number of polynomials. I can multiply this through by negative 1. I can multiply it through by 5. I can multiply it through by 537. It doesn't really matter because the zeros will never change. It's just the coefficients that will change. So this is the general form, but if asked, and I believe your homework asked for a single one, a solution. So one of the solutions is most definitely f of x is equal to x cubed minus 2x squared minus 5x plus 6. But I need you to understand that this is the infinite and general solution to the question, and we could get every single solution to this question using that general form. Okay, let's do a couple more examples. I'll give you a u to do too. Let me do one more example here before I do that. Again, we're still find general form. Find the general form. With zeros of 0, 5, and negative 1. Okay, so first things first, I'm going to turn these guys into factors. The factor for 0 is x minus 0, which is just x, right? So our 5, we're also going to have x minus 5. And for our 1, we'll have x minus a negative 1. Okay, so these are what we're going to multiply together. So our factors are, I just want to clean that up since I talked about it right there. I don't want you to think that all that is part of it. These are our factors. Now I'm going to FOIL these two guys together first. and then I'll multiply that x in at the end. That's just the way that I'm going to do it here. So we have x squared minus 4x minus 5 from that piece times this x. So our general form is x cubed minus 4x minus 5x quantity multiplied by a, and one solution here is, and they might ask you for the, and I think they ask this way in the homework, for the leading coefficient to be 1. I think they even have that in the directions, which was kind of weird directions, but that way you know when you read that weird direction in the homework. So y is equal to x cubed minus 4x squared minus 5x, or we could have used an f of x. You know that y and f of x are exactly the same. Okay, so let's have you do a you-do. Let you practice this real quick. Let's see, our zeros are going to be 2, -3, and 1. And a lot of times they like to be explicit and tell you what the degree of the final polynomial is here. And so here the degree of the polynomial is going to be 3. Okay, so let me give you a couple minutes. You want to be sure to start with writing your stuff in factored form. You got quite a bit of foiling to do here. Remember, you can only do 2 at a time. I love doing that kind of stuff on scratch paper. That way it doesn't dirty up all of my actual work, so I don't get confused with my side work and the problem I'm working through. Just helpful hint. Okay, if you haven't finished, I'm going to encourage you to pause right now and finish the problem, and then jump back in when you finish the problem. But let me go ahead and work the problem. So first things first, we're going to get our factors: x minus 2, x minus a -3, x minus 1. I'll multiply these two together first. We have x squared plus x minus 6 multiplying it by an x minus 1. So I'm just going to knock it out here. We have x cubed minus x squared plus x squared minus x minus 6x plus 6. Clean that up. I'm going to write it over here. Looks like we have f of x is equal to a times, let's see, x cubed. Looks like these x squares cancel. Plus and minus 1. So then minus 7x plus 6. And for your answer, so this is general form. And then the answer, like your homework's going to ask you for, which is where the leading coefficient is 1, is going to just be this x cubed minus 7x plus 6. Okay, very good. So one other thing that can be done with this is asking you to find a specific equation that comes through a specific point. So let's see how that changes the equation here. So find the polynomial with the given zeros of 0, -1, multiplicity 2. I'm going to talk about that in a minute. And 3, multiplicity 2. It's also going to tell us that it is going to be a degree 5 and through a specific point 1 and -48. Okay, now let's unpack this a little bit. First things first, multiplicity you should already be familiar with, but if you're not, that means that there is that factored twice. Okay, so that means we have a x plus 1 and an x plus 1. Or here we have a x minus 3 and another x minus 3 because it's multiplicity 2. If it was multiplicity 3, you'd have them 3 times. Okay, so let's get started. First, we want to write the factors. So we're going to start the same way. We're going to write the factors and find the general form. All right, so we have our factors are x plus 1, multiplicity 2, I could write it like that, and we have x minus 3, multiplicity 2. Now, by the way here, if you take a look at this, we have this, and it is in factored form, and it is beautiful. You're in this class because you're moving on to higher math for sure and using higher math. So it is important that you can recognize that this is already in factored form. Now let's take a look at how to finish this up. Okay, so we already have the problem in factored form. We could multiply it all out. But as I told you, as we go further on, the more we leave things in factored form, the more useful they are to us. Now, homework in this section is going to expect you to multiply this out. But I'm not teaching you to the homework, okay? So I'm teaching you
to be effective in your calculus sequence and beyond in your courses that require you to use this higher level thinking with mathematics. So I am going to show you how to solve this equation for A and get it in its factored form without multiplying it completely out and doing it like that. So that's how I'm going to work this problem. If I find that I need to do it the other way, I will. If you find that you can't follow what I'm doing and you need to see it in a different and more explicit way, then please reach out an email and I'll get right to it. I don't necessarily have to meet you alone. I just need to know like where you guys stand. So if you, certainly in these early week here, any sort of feedback is great. I generally teach this class in a classroom and I can look at your face and that is enough feedback for me. But here I don't have your faces to look at to see if you understand what I'm doing or if I'm going off the rails. So let me know. Okay, here we go. Back to this. Okay, so these are the factors, and if we were to put it in general form, let me write it in general form. This is going to be the f of x is equal to a times x plus 1 squared times x minus 3 squared. And now what we want to do is we want to use the point and solve for a. Okay, and so here was our point. It was 1 and negative 48. Remember that points are x and f of x. Okay, so I can say negative 48 is equal to a times, and then I'm going to plug in for my x. 1 times 1 plus 1 squared times 1 minus 3 squared. All right, so let's see what this is. 1 times 2, that's 2 squared is 4. And then this is negative 2 squared is also 4. So I've got negative 48 is equal to a times, and what is this number here? 4 times 4 is 16. Divide both sides by the 16, of course, and we get a is equal to negative 3. So our solution to our question is going to be f of x is equal to negative 3 times x plus 1 squared times x minus 3 squared. Now, your homework's probably going to ask you, just because it's this section and they're not really going to expect me to show it most likely to you in this manner. I think this saves so much time and energy to do it this way. You may be asked to multiply all this out for the actual answer there. Just be aware. You know what to do from there though, right? Let me finish it. I don't want anyone saying that I didn't show it. So let's just do it. Let me just over here, I'm just going to multiply this out. This x times x plus 1 squared times x minus 3 squared. Let's do it. So we're going to have x times x plus 1 squared is x squared plus 2x plus 1. You should remember that from your earlier algebra where you can do that, but it's the first term squared, the sign stays the same, 2 times the two terms multiplied together, and the last times the last. So this, if I do it using that idea, I'm going to have x squared minus 2 times 3x is 6x plus 3 times 3 is 9. Now let me multiply these two guys together. So I have x to the 4th minus 6x cubed plus 9x squared plus 2x cubed minus 12x squared plus 18x plus x squared minus 6x plus 9. Come down here, I got x to the 4th minus 4x cubed minus 2x squared plus 12x plus 9. So this would be, I'm still working on it, -3 times this crap, x to the 4th minus 4x cubed minus 2x squared plus 12x plus 9. And so finally, if I was really cool, if we were not having an online class, I would not require this. I would leave it in the factored form because that's really the desired form, and you would never be putting it from factored form back into something that's non-factored. There's the final answer. Okay, let me do one more like that, and then we're going to be done. Let's do zeros of 1, -2, multiplicity 2, and then through the point -1 and 4. Okay, so first things first, let's get our factors. Our factors here are x minus 1 and x minus a -2, multiplicity 2. So now let's set it up here. F of x is equal to a times, that's factored form we just wrote out. Okay, now we're going to plug in our point, the point being -1 and 4. So we're going to say 4 is equal to a times, let's just crank it all out here, -1 minus 1 and -1 plus 2 squared. And we'll finish this up here. 4 equals is a times whatever we're going to figure out over here. -1 minus 1 is -2 times -1 plus 2 is 1 squared. So -2 times 1 squared is a -2. And so we get a is equal to -2. And so our final answer here is f of x is equal to -2 times x minus 1 times x plus 2 squared. And if we were so inclined to FOIL that out, or if we were doing our homework, I guess that's what you guys are doing, so I'll FOIL it out here. I feel like I've done this already today. And we have x cubed plus 3x squared. These guys cancel, minus 4. And then we have all that crap times a negative 2. So f of x is equal to negative 2x cubed minus 6x squared plus 8. Okay, so there we have it. We've got the first week down. Yay! And you guys have a good day.